this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, Greatest Common Factor. Now, our directions for this entire worksheet are to find the GCF, otherwise known as the greatest common factor, of each. Now, in previous lessons, we went over how to find the factors of numbers. The greatest common factor is the greatest factor that divides all of the numbers given. So let's take a look at number 1. In number 1, we're going to find the greatest common factor of 39 and 6. What I like to do is take the smaller number and find the factors of it. So looking at 6, the factors of 6 are 1 and 6, and then 2 and 3. So from those factors, we're going to ask ourselves, which of these is the greatest one that also divides 39? So 1 divides 39, so far that's the greatest. 2 does not divide 39, so 1 is still the greatest. Does 3 divide 39? Yes, 3 does divide 39, because 3 plus 9 equals 12, and because 12 is divisible by 3, 39 is divisible by 3. And if you don't know that divisibility trick, take a peek at one of my previous videos. But if we sum the digits together, if that number is divisible by 3, then the overall number is divisible by 3. So I know that 39 is divisible by 3. So that's now our greatest common factor. Let's ask ourselves, is 39 divisible by 6? And no, 39 is not divisible by 6 because 6 times 6 is 36. And then the next number, 6 times 7, would be 42. So unfortunately, 39 falls in between those, so 6 does not go into it evenly. So 3 is going to be our greatest common factor. So again, 3 is our greatest common factor in number 1, the greatest number that divides both 39 and 6. Let's move on to number 2. In number 2, we're looking at 24 and 28. So let's write the factors of that smaller number 24. So 1 and 24, then we have 2 and 12, then 3 and 8, and then finally 4 and 6. Now let's ask ourselves, 1 divides 28, but that's not the greatest number because 2 also divides 28. So right now, 2 is our greatest number. But does 3 divide 28? No, 3 doesn't divide 28, so 2 is still our greatest number. Does 4 divide 28? Yes, 4 divides 28, so now 4 is our candidate for the greatest common factor. Because even though 2 divides both of them, 4 is a bigger number that divides both of them. So next we'll check 6. 6 doesn't divide both. 8 doesn't divide 28. 12 doesn't divide 28. And 24 doesn't divide 28. So 4 is our greatest common factor. Let's move on to number 3. In number 3, we're looking at 40 and 10. So writing the factors of 10, that's 1, 10, 2, and 5. I know that 1 divides 40. I know that 2 divides 40. 5 also divides 40. But our greatest common factor is 10 because 10 divides both 10 and 40. So because 10 divides both, 10 is our GCF. And finding the greatest common factor is helpful when simplifying or factoring. So make sure you understand how to find the GCF because that will make factoring a lot easier. Let's move on to number 4. In number 4, now we're switching things up a bit, but only because we're putting a variable in. But remember, a variable represents some number. So I'm just going to look at our integers that are multiplied first. But if you notice, we have v and v in common, so v is going to be a part of our GCF. So for 30, the numbers that divide 30 are 1 and 30. We have 2 and 15, 3 and 10, and then 5 and 6. Now, the greatest common factor between just the number 39 and just the number 30 would be a 3. Because 5, 6, 10, 15, and 30 do not divide 39. Neither does 2, just 1 and 3, but 3 is that larger one. So our greatest common factor between the number 39 and the number 30 is 3, but both of them also have a v in common. Not the u. The u is only with 30, but because each of them have one v, my greatest common factor is 3v. Because 3 times v goes into 39. Look, 3v times what gives us 39? That's going to be 3v times 13. Gives us 39v, and then 3v times what gives us 30uv. That's going to be 10u. So if we're unsure what our greatest common factor is, if we think we've got it, we can double check by seeing what multiplies together to get those original numbers and see if they have any factors in common. If they do, then I can pull those out and combine them with what I originally thought was my GCF. So, for example, if I didn't realize that v was a part of each of my numbers, and I just had 3 as my greatest common factor, I'd have 3 times 13v to get to 39v, and I would have 3 times 10uv to get to 30uv, but I can see that I have a v in common, so I can also pull that out, putting it with my 3. So again, one more time, our greatest common factor in number 4 is 3v. Now after that little more in-depth explanation, let's go ahead and move on to number 5. In number 5, we have 35n squared times m, and then we have 21m squared times n. Let's work on the numbers first. 21 and 35, if I look at my factors of 21, that's 1 and 21, and then 3 and 7. So 1 divides 35, 3 does not divide 35, 21 doesn't, but 7 does divide 35. So 7 is going to be part of my factor. So if I pull out a 7 from each of those, what else is in common? Well, here I have n squared, and here I have an n, so I know that I at least have one n in common. And here is an m, and here is an m squared, so that I know I at least have one m in common. So 7 times n times m is my greatest common factor. And then again, let's quickly double check. 7nm times what gives us 35n squared m? That would be 5n. And then 7nm times what would give us 21m squared n? That would be 3m. That would give us 21m squared n. And looking at 5n and 3m, there's no common factor between those besides 1. Therefore, we know that 7 times n times m is our GCF for number 5. Now, moving on to number 6. Looking at my numbers first, 30 and 20. What divides 20? That's 1 and 20, 2 and 10, 4 and 5, and that's about it. 1 divides 30, 2 divides 30, 4 does not, 5 does, but so does 10. 20 doesn't, so 10 is our greatest common factor among just the integers or just the coefficients of our variables. So we know for a fact that we have 10, but 10 is not all we have. 30y cubed and 20y squared have at least two y's in common, because think about 30y cubed as 30 times y times y times y, and 20y squared is 20 times y times y. I have 2 y's and I have another 2 y's. I don't have 3 y's over here, so I can only take 2 of them. So the GCF is going to be 10y squared. 10y squared is my solution in number 6. In number 7, we're looking at 54 and 45. Right away, I know that my GCF is going to be 9. And the reason I know that is because I know this really neat multiply by 9 finger trick where 45 and 54 I can easily get to. So check out that video if you want to see that really neat trick. I'll leave a link in the description below. Trust me, it will make your life 100 times easier when multiplying by 9. But if you didn't know that 9 was the GCF, let's go about how to get that. 45, the factors are 1 and 45. Does 2 go into it? Nope. 3 does go into it. 3 times what gives us 45? That would be 15. And then 4 doesn't go into it, but 5 does. And that's 5 times 9. Is there any number between 5 and 9 that goes into it? 6, no. 7, no. And 8, no. So these are my list of factors. Working left to right, 1 goes into 54. 3 goes into 54. 5 does not. 9 does. 15 does not. And 45 does not. So 9 is the greatest one. In number 8, I'm working with 25 and 55. So I'll list the factors of 25. I have 1 and 25. 2 does not divide it. 3 does not divide it. 4 doesn't, but 5 does. That would be 5 and 5. There's no other number between these two that divide 25. Therefore, those are my factors of 25. 1, 5, and 25. Now we're going to see what's the greatest one that goes into 55. 1 goes into 55. Does 5 go into 55? Yep, because it ends in a 5, and 25 does not. So my GCF in number 8 is 5. Moving on to number 9, I have 68 and 34. Both are even, so I know that 2 divides them. Let's write out those factors of 34 at the start though. So that's 1, 2, that would be 34 and 17. And no other number divides 34 evenly between 2 and 17. So 1 divides 68, 2 divides 68, 17 times 4. I'll do 7 times 4 because that's 28. Write the 8, carry the 2. 4 times 1 is 4 plus 2 is 68. So that shows that 17 divides 68. But also 34 divides 68 because 34 times 2 is 68. So 34 is the greatest common factor of 68 and 34. Now on to number 10. We have 54 and 27. If we're looking at 27, I know that 27 goes into 54. 27 times 2 equals a 54. So the greatest common factor of both of those is going to be 27. Because think about it. If 27, the greatest factor that goes into 27 is itself. And if that also goes into 54, well, then that's the greatest common factor of both of them. Because there's not going to be a number higher than 27 that I can find that goes in for both. So 27 is my solution in 10. Number 11, we have 55 and 75. So 55, writing out those factors, is 1, not 2, not 3, not 4. 5 times 11 gives us 55. So 1, 5, 11, and 55, I know are factors of 55. Is there anything else in between 5 and 11 that multiply to give us 55? No. So those are my factors of 55, and I know that 1 goes into 75, 5 goes into 75, 11 does not, and 55 does not. So my GCF in number 11 is 5. In number 12, I'm looking at 66yx and 30x squared y. Let's look at our variables first just to switch things up. If I have yx and x squared y, I have one y here and one y here, so I can pull out a y. I also have one x here and two x's here, so I can only pull out a maximum of one x. So I know that my solution is going to be multiplied by xy for my factor. Now I just got to look at those numbers, 30 and 66. Writing out the factors of 30, that would be 1, 2, 3, 5, 6, 10, 15, and 30. Looking at this compilation of factors, the greatest common factor between this and 66, let's ask ourselves, 1 goes into 66, 2 goes into 66, 3 goes into 66, 5 does not, 6 goes into 66 because that's 6 times 11, 10 doesn't, 15 doesn't, and 30 doesn't, so 6 is my GCF for just my numbers. So overall, my greatest common factor is going to be 6xy. 6xy is my solution in number 12. You could also write this as 6yx. Because multiplication is commutative, the order in which we multiply doesn't matter. So 6xy and 6yx are the same exact value. Because remember, x and y are just variables. So if x was 2 and y was 4, that would be 6 times 2 times 4. Or 6 times 4 times 2. Either way, we'll get the same result. Let's move on to number 13. In number 13, we have 60y times 56x squared. Right away, looking at my variables, y and x squared do not have anything in common, so there will be no variables as a part of my GCF. So now I'm just looking at 60 and 56. Finding the factors of 56, that's 1 and 56. 56 is divisible by 2, so that would be 2 and 28. And then splitting that up, 56 is not divisible by 3, but it's divisible by 4. That would be 4 and 14. And then lastly, I have 7 and 8. So out of these, which one also goes into 60? 1 does, 2 does, 4 does, 7 does not, 8 does not, 14 no, 28 no, and 56 no. So 4 is going to be my greatest common factor for number 13, especially since my variables had nothing in common. So 4 is my GCF. In number 14, I'm dealing with 36xy cubed and 24y squared. Looking at 36 and 24, let's see what their greatest GCF among just the coefficient values are. So I'm looking at just my greatest common factor of just 36 and 24, and I'll look at the variables in a second. So listing out my factors of 24, that's 1 and 24, and then we have 2 and 12, 3 and 8, then 4 and 6. I know that 1 goes into 36, 2 goes into 36, 3 goes into 36, 4 goes into 36, because that's 9 times 4, 6 goes into 36, that's 6 times 6. Does 8 go into 36? No, not quite, because 8 times 4 is 32, and 8 times 5 is 40, so 8 doesn't. Does 12? Yeah, 12 times 3 equals 36. Does 24? No. So our greatest number is 12, so I know I'm going to have 12 multiplied by something else, because x times y cubed and y squared, let's first look at the variable x. We have an x over here, but do we have an x over here? No. So x is not going to be a part of that GCF. We have y cubed over here and y squared over here, so y will be a part of it, but how many of them? Over here we have y times y times y, whereas with 24y squared, we just have y times y. So I'm going to take 2 of those y's. So 12y squared will be our greatest common factor for number 14. In number 15, we have 18y squared and 54y squared. Right away, my variables are the same, y squared and y squared, so I know my solution will have a y squared in it. Now, let's figure out the greatest common factor among 18 and 54. Well, 18 goes into 54. 18 times 3, 8 times 3 is 24, carry the 2, 3 times 1 is 3, plus 2 is 5. 18 times 3 equals 54. So because 54 is divisible by 18, the greatest common factor is going to be 18y squared. Now moving on to number 16, we have 80x cubed and 30yx squared. I'll go ahead and just start with my coefficients now. 30, the factors are 1 and 30, 2 and 15, 3, 10, then 5, and 6. So let's ask ourselves, 1 goes into 80, 2 goes into 80, 3 does not, 5 goes into 80, 6 does not, 10 goes into 80, 15 does not, and 30 does not. So 10 is my greatest number that goes into both, but now let's check out those variables. I have x cubed and yx squared. Right away, I know that I don't have a y in common, but among x cubed and x squared, I have two x's in common, so that's x squared. So 10x squared is my GCF for number 16. And again, if you want to see how I do my variables, x cubed is x times x times x, whereas x squared is x times x. So the most I have over here are 2, and the most I have over here in the first number is 3, but I only have a maximum of 2 here, so I can only take a maximum there. So that's 10x squared. Now, on to number 17. We mix things up just a little bit more because now we're finding the GCF among 3 separate numbers, but the same kind of rules apply. The greatest common factor needs to divide all 3 and be the biggest number or expression that divides all 3. So let's start with that smaller coefficient of 30. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. 1 times 30, 30. 2 times 15, 30. 3 times 10, 30. 5 times 6, 30. Now, we have to ask ourselves which ones divide. Let's try 75 first. So I'm going to circle all the factors that divide 75. That's 1, 3, 5, and 15. Now, I know that 15 is my greatest number between 30 and 75, but I have to see what my greatest number is between all of these together. So knowing that 1, 3, 5, and 15 are the numbers that 30 and 75 have in common, I need to see if 105 has any of those in common as well. So I'll use a different color to represent 105. And let's go ahead and just highlight it. So for 105, 1 divides 105, 2 does not, does 3. 3 does indeed divide 105, so does 5. I don't even need to check 2, 6, 10, or 30 because 30 and 75 didn't have those in common, so it doesn't matter whether 105 does or not. All 3 of them need to have the same common. So far 1, 3, and 5 are in common. The last one to ask ourselves is 15, and yes, 15 also does divide 105. So 15 is my number. Now I'm going to look at my variables. I have 105x, I have 30 yx, and I have 75x. I have an x in each of those, but a y only in one, so I have 15xx as my greatest common factor. And again, remember that multiplying trick to decide if we did indeed have the greatest common factor? Let's double check. I'll do 15x, and I'll be multiplying that by 3 different numbers or expressions. One will give me 105x, the other will give me 30yx, and the other will give me 75x. So what will those numbers be? Well, let's start with 105x. 15x times 7 equals 105x. Now the next one, 15x times what, gives me 30yx. That's going to be 15x times 2y. And then the last one, 15x times what, gives me 75. And that's going to be 5. 15x times 5. Now, as you can see, there's no common factor between 7, 2y, and 5. So we did indeed pull out the greatest common factor at the start. So again, 15x is our solution in number 17. Lastly, on this worksheet, are you ready? Here we go. First of all, we have to see, let's start with our coefficients. So 80, 140, and 140. And this one's actually going to be a little bit easier because 140 are the same number. So as long as I find that greatest number that divides both 140 and 80, it will also divide this 140. So thinking about those factors of 80, that would be 1 and 80, 2 and 40. 3 does not divide 80, 4 does. That would be 4 and 20. 5 divides 80, that would be 5 and 16. Is there anything else? 6 does not, 7 does not, but 8 does. So let me rewrite these, stretching them out a bit. So 1, 2, 4, 5. Now we have 8, and 8 times 10 is 80. So then I'll write the rest of my factors, 16, 20, 40, and 80. So now we just have to ask ourselves, which of these also divides 140? 1 does, 2 does, 4 does, 5 does, 8 does not, 10 does, 16 does not, 20 does, 40 does not, and 80 does not. So 20 is the greatest number that divides both 80 and 140, and therefore also this other 140. So I'll have 20 for my number. Now I'll look at my variables. For variables, I have n, m squared, and m squared. So among these two numbers, I have an m squared in common, but I have no m over here, and these two do not even have an n. So I don't even have a variable that all three of these have in common. So 20 is my GCF in number 18. Now, if you found this video helpful, remember to give me a thumbs up, subscribe to my channel, and share it with somebody that you also think will find this useful. If you want more ways to support me, become a patron. Check out that Patreon link for more information. Also, just so you're aware, I try to respond to comments as soon as I can on YouTube, so if you have a specific question, post it in the comments below, and I or one of your peers will get back to you ASAP. But, as always, don't forget to like, subscribe, and share.